Hello everyone, back tuning into the 4th Winter 2020-21 update, part 1 from GavsWeatherVids. So here we go again, another winter update for you, and I shall get on with it for you in a moment. Going to be looking at things like sea surface temperature anomalies, what's happening with Eurasian snow cover, solar activity, and Atlantic hurricane activity too, as well as other things as well. So I shall get on with that for you very shortly. Just to say that part 2 will be coming up tomorrow from 6 p.m. So a new time for the part 2s of winter update. 6 p.m. on a Monday will be the new release time. So yeah, that could be like analog space. We'll start looking at some September data this week for the second part of the 4th winter 2020 update, and that's going to be coming up for you, as I say, tomorrow at 6 p.m. So I shall get on with the first part of the 4th winter update in a moment. Just to say that it's going to be quite a long video, as usual, with the long range update. So you can't watch it all on go, then don't worry, it will be kept on winter updates page at GavsWeatherVids.com indefinitely. There'll be a written summary that goes with it as well. And I'll get that up for you on winter updates page, hopefully tonight. If not tonight, it'll be early tomorrow morning. But I will endeavour to get that up for you very shortly later on today. So big thank you to Richard for the winter updates gift. Thank you so much, Richard, for this year's winter 2021 updates gift. We're going to be live streaming after 6 o'clock this evening. So from 6 p.m. we're going to have a live stream. We'll check in, see how we're all doing. We'll look at some winter data. I don't know what we're looking at yet. Almost certainly CFSB2 data, I would have thought. We'll be taking questions. It'll be fully interactive and all of that good stuff. That'll be coming up from 6 o'clock this evening. Okay, so I think that's pretty much everything I've got to tell you. Let's get on then with the 4th Winter 2020-21 update, Part 1. So we're going to begin with the Swingometer. So here we go, a little bit of fun, my little Peter Snow impression. So just a bit of fun. So look at this. This is based on the 3 winter updates that we've done so far. This has been sent through by Richard Traut, our king of swing. So look at this though. Since last week, we have actually had a swing to cold. We have actually had a swing to cold since last week's 3rd winter 2020-21 update. So we have swung from mild to cold, and we have 54% now favouring cold, and 46% with our swingometer favouring mild, a mild winter. So yes, after 3 winter updates, and particularly last week's update really did move the swingometer quite a bit. After last week's 3rd winter update, we had a swing from mild to cold, and so yes, 54 to 36, 54 to 46% favouring a colder winter after 3 winter updates, and particularly that did move a lot after last week's 3rd winter update. Thank you so much to the King of Swing, to Richard, for getting that together for us. And you'll see the swingometer next week again. And of course, we'll see how this 4th winter update, parts 1 and 2, how this 4th winter update moves the swingometer. If it does move the swingometer, will there be a further swing from mild to cold? Will we see a swing back from cold to mild, and could we just stay where we are? So you'll find out next week how the swingometer is looking after this 4th winter 2020 update. But yeah, quite a significant movement, actually, quite a significant move from the swingometer after last week's 3rd winter update. I was quite shocked when I saw that, when Richard sent it through to me. But there we go, the computer does a lot, and so that's what our swingometer is showing this week, a swing from mild to cold as the most likely outcome for winter 2020-21. Thank you so much to King of Swing, Richard Shaw, sending that through. Right, QBO. I thought we'd start with the QBO for this. So here we go then. This is like getting the fourth winter update up and running. So of course we know that the QBO very, very much a mystery at the moment. We should be in the easterly phase of the quasi-biennial oscillation. We should have seen this blue-green area descending down from the stratosphere into the troposphere, and we should be well and truly locked into a strong and mature easterly QBO phase. Now, what actually happened is that the westerly QBO did not go. This sandy coloured area just here is the westerly QBO within the troposphere. You have to look at this and think of this as like the levels of the atmosphere. So this is right at the top of the strat. That's at 10 HPA up there, right at the top of the stratosphere. This down here is where we're all going to be walking around on the floor. And the all important level, of course, is the troposphere, which over here is kind of like 30 to 50 HPA. That's the boundary level of the atmosphere where weather is taking place. So 30 HPA is kind of like the top of the troposphere. So you can see that within the tropospheric level, the westerly QBO continues. So the last proper easterly phase of the QBO is back in 2017-18, this blue-green area just here. Then we have, of course, the last proper westerly QBO, which was 2018-2019, this sandy coloured area here. You see how these phases are descending down from the stratosphere through the troposphere and lower. So easterly there, westerly there. Now, of course, we've got the easterly QBO up here. This is the beginnings of the easterly QBO, and this should have descended down through the troposphere. But what actually happens is that the westerly QBO just doesn't quite go. Look how these raggedy sort of areas continue. These raggedy peaks and troughs continue through the troposphere until we get into the summer of 2020, when there is a strengthening of the westerly QBO. Westerly QBO sort of comes back rather than going easterly. Now, if we zoom in, we can see, this is from NASA, by the way, so if we zoom in, we can see that at the very top of the atmosphere and the stratosphere, we've still got a signal for the easterly QBO to be lurking there at the very, very top of the stratosphere. But in the troposphere, in this level just here, we still have the westerly QBO continuing. So we're still in this sort of phase of not knowing where the QBO is going. Is it going to stay weak westerly? Are we going to see the westerly QBO strengthening and powering up? Will the easterly QBO be able to come back? We still are waiting to see where this is going to go, and it is still such a mystery. It's an enigma wrapped up in a mystery and all of that sort of thing. So yeah, where is the QBO going to go? The reason we look at this is because the easterly phase of the QBO favours a weakening of zona westerlies. Basically, the QBO is a way of measuring the strength of the zona westerlies, if you like. So when you're in an easterly QBO, you weaken the zona westerlies. You have an increased risk of blocking, therefore, particularly in the winter. And blocking, of course, is the route to getting cold air out of the pole and down into mid-latitude. But conversely, when you're in a westerly QBO, you kind of favour strengthening westerly zona westerlies. And so a westerly QBO kind of goes with increased risk of a milder winter. But then again, there are exceptions. There are always exceptions to the rule. So we do get a lot of easterly QBO winters that are mild, and we get a lot of westerly QBO winters. We get a few westerly QBO winters that are cold. Now, next week on the 5th winter update, we're going to be able to give you September's QBO number. This is from NOAA, so this is depicting showing all months QBO numbers all the way back into 1950s. For example, you can see that in 1963, the daddy of cold winters was a strong, mature easterly QBO winter. Easterly QBO actually began in the spring and early summer of 1962 and powered up into the winter of 1963 before it reverses back into westerly QBO at the end of 1963, late on in the year. But the daddy of cold winters, 62-63, was an easterly QBO, indicated by those negative numbers. Now, if we come down here, you can see that in 2020, we actually begin the year with the easterly QBO beginning to develop. So January, we have minus 2.5 3.51. February had minus 3.20. March had minus 4.36. April we had minus 5.03. That's like the peak of the easterly QBO, if you can call it that. It's barely into the easterly QBO, but that's like the peak of it. And then May, we see a weakening of that easterly QBO, which continues into June, and then we actually get a reversal of the easterly QBO in July and in August, where the QBO numbers start going positive again. So the last number that we have for August 2020 came in at plus 4.78, weak westerly with the QBO for August 2020. Now we wait to see what's going to happen with September's number. I wouldn't expect it to be all that much different from August. I don't think the westerly QBO has strengthened further, or I'd be surprised if it strengthened further. It may even have weakened ever so slightly compared to August. So where will that number come in next, when this updates next month, the start of October, to show us September's number? Where will that QBO number come in? It'll be fascinating to see. But I don't think it'll be all that different from August. So we may have arrested like the reversal into westerly QBO for the time being. We might have done. Remember, it's all speculation. I don't know for sure. We might have arrested the reverse, but we certainly haven't gone back into the easterly QBO. I don't think there's any chance of getting a negative number here. I think it'll still be like weakly westerly. But we shall see when NOAA updates next week, and I'll be able to bring you that in the 5th Winter 2020-21 update next weekend. Right, solar activity looking like this. So this is how the solar disk is looking on our side today from solarham.net. We have a spotless solar disk. There are no visible sunspots at all. So solar activity is therefore at very low levels and is expected to remain at very low levels for the next 3 days. This is the GavsWeatherVids solar activity tracker, updated by James Ackrill, keeper of the solar tracker. James has updated this up to the 26th of September. So we had like a month without any sunspots. That did get broken though a couple of days ago. So the orange line here is depicting each individual day's worth of sunspot activity, and you can see how the orange line is sort of flatlining on the floor of the chart there, like from the middle of August to into the second half of September. But look at that, we just get this very minute, tiny little sunspot appearing a couple of days ago, but did break sort of that run of spotlessness a few years ago, like hundreds of years ago. That probably would never have been measured, that sunspot. But the telescope's so good now that they can measure these things on the satellites. But anyway, so we get this one sunspot, and now we're back down to spotlessness again. That one sunspot has not been enough to lift our trend lines upwards though. So the thick green and the thick red lines, they are the trend lines, and they are still flatlining away on the floor of the chart. That one sort of sunspot on one day was not enough to move the trend lines. So we remain at a very low level of solar activity. We are 9 months into solar cycle number 25, and we continue to be at a very, very low level of solar activity, comparable to what we saw was in true solar minimum, back in 2019. And so on. So yeah, we're in a real sort of minimum phase of the solar cycle, albeit we are into the early part of solar cycle 25, but it's a very slow start to solar cycle 25, to say the least. This is from Richard Traut. So this is my good friend Richard, showing spotless days and the current spotless stretch by year and by days. So here we go then. For the current spotless stretch, only 3 days, because of course I just explained we did get that one day with a sunspot a couple of days ago. So at the moment, 3 days of spotlessness. For 2020 overall, we have had 192 days without any sunspots. That is 71% of the year, comparable 2019, which is the solar minimum year. We know now from NASA that solar minimum for solar cycle 24 occurred in December of 2019, and so 2020 is like the first year of solar cycle 25. So it compares to 2019, which had 281 days without sunspots. That is 77% of the year. This is all very, very similar to what happened from the solar minimum of solar cycle 23 to 24. Look at solar cycle 23's minimum year in 2008. Had 268 days without sunspots, 73% of the year. 2009, the first year of solar cycle 24, had 260 days without sunspot, 71% of the year. Actually, it looks like this solar minimum has been deeper. Really, the solar minimum of solar cycle 24 to 25 has been deeper than the solar minimum of solar cycle 23 to 24, in my opinion. So I think this is an even deeper solar minimum, and it's taking even longer to start pulling out of this solar minimum. So it'll be very interesting to see what impacts this could have on the winter. Later on in winter updates, we're going to have a look at, through reanalysis, at how solar minimum winters come out, and like the first winters of the solar cycle. So that's going to be really fascinating to look at in a future winter update. Big thank you to James and to Richard for sending through the data. Arctic oscillation observed and forecast looking quite interesting at the moment. So the AO is just an index that's reflecting the atmospheric state, similar to like the QBO, really. It's just telling us what the atmosphere is doing over the Arctic. So when the AO is in its positive phase, got low pressure up over the Arctic. When the AO is in its negative phase, got when the AO is in its positive phase, got low pressure up over the Arctic. When the AO is in its negative phase, got high pressure blocking over the Arctic. So through September, the AO has actually been in a positive phase through most of it. We're currently there around weekly positive, but the GFS ensembles as we go into October are forecasting the AO to go negative. So that tells us that we're going to move from low pressure being over the Arctic to high pressure being over the Arctic. It looks like we're going to get blocking setting up over the North Pole. Blocking, of course, is the route to pushing cold out of the pole and down into the mid-latitude. Now, it is only October, so the amount of cold that we can push out of the pole into mid-latitudes is going to be reduced. But that is definitely a signal as we go into October for northern blocking to be developing. The NEO is very similar. Again, the black line shows where we've been with the NEO. The red lines are the end where the GFS ensembles are forecasting the NEO to go through most of September, even back into August, through the past few weeks. The NEO has been in its positive phase. That tells us that we've been in a westerly type sector. We've had low pressure around Iceland, had high pressure through the Azores, and we've been strengthening the zone of westerlies. Where we're actually at with the NEO right now is around neutral, but the GFS ensembles are forecasting that the NEO as well is possibly going to go negative. So with both of the indexes going negative into October, this could be a signal for colder weather to come, really, into the mid-latitudes, and maybe a northern blocking type signal as well. Now, this is from weatheriscool.com. This is showing the strength of zonal winds at 10 HPA over the North Pole. Now, they've added new lines to this, so it makes it much more complicated now for me to talk about this. So I've got to tell you what all of these coloured lines are depicting once again. I went through this like in the first update, and I was hoping I wouldn't have to do it again. I'd just be able to refer everybody back to like the first update. But as they've added new lines, I've got to go through all of this again. So I suppose the most important line is the black line just here, because that is the seasonal trend. So at this time of the year, we've got our dates on the bottom, monthly periods, of course. So this is September, this is October, this is November, and this is December. That will be January just there, that'll be February just there, and that will be March. So at this time of year, zonal winds should be strengthening. This is like the engine that powers the polar vortex, if you like. So the solar winds get stronger and stronger and stronger through the autumn and into the winter, and that is a powering up of the west. Remember, this is in the stratospheric level at 10 HPA over the North Pole. So this is where the energy comes from, if you like, that drives zonality and drives westerly. So this time of the year, solar winds are getting stronger. Now, what else am I going to tell you with all of these different coloured lines? So the red line just here is last winter, so that's polar vortex of doom, this red dashed line. very regularly through last winter, the polar vortex of doom produced record-breaking strong zonal winds. You can see how strong those zonal winds were. Now, where we currently are is just here. That's on a blue line, which is a little bit difficult to make out, but we're very close to average at the moment in terms of the strength of zonal winds. These green lines just here are the GFS ensembles. So the GFS ensembles are forecasting that zonal winds at 10 HPA will actually become a little bit weak on average in the next few days, and then possibly return close to, or maybe a little bit stronger than average as we go into like the second week of October. That's as far as we go with the GFS ensembles. Beyond that, we have to pick things up with the blue lines, which is the CFS-V2. So these 4 blue lines are from the CFS-V2. Again, we've got October just here, we've got November just there, we've got December just there, as far as we can go. The blue lines are generally under average. The blue lines are generally under average, under that black line, through to the end of December, with a couple of them actually going for a reversal of zonal winds during December. That will probably be in association with a sudden stratospheric warming. Now, so that's CFS-V2. It's the long-range bomb run 4 times a day. Now, what the pink lines are showing is CFS bias corrected. So I don't know how they're doing this at Weather is Cool, what they're basing this on, but they're saying, I suppose, that the CFS-V2 is biased towards having weaker zonal winds than will actually be the reality, and somehow or other they're managing to correct that bias, or they think they're correcting that bias with these pink lines. So you can see that even the pink lines, though, during particularly November and to some degree December, are kind of under average as well. Even correcting the bias within the CFS-V2, zonal winds are still being forecast by most of those pink lines, most of the bias corrected lines, still being forecast to be weaker than average. Although by the end of December, we do see that some of those CFS-V2 members are getting a little bit stronger. So have I got that right? So let's check that again. So yeah, this is going to be September, isn't it, just here? That's going to be October. That's going to be November. That's going to be December. Right, that's okay. So the pink line, the pink lines are getting a little bit stronger as we get through to to December. They're picking up to go a bit above average, some of them, but other ones of those pink lines are staying weaker than average. It's very, very complicated, this. I wish Weather is Cool hadn't done it. So if anybody's watching this from weatheriscool.com, I'm not impressed with this, I have to say. It's made it vastly more complicated for me to tell you what this is showing. But basically what you need to know is that blue lines like raw CFS-V2 data, pink lines is CFS-V2 corrected, with the bias corrected, but it's a beta idea, so they're just testing it out, I suppose. I don't know how they are correcting that bias that they are seeing, and it does make it vastly more complicated for me to tell you what this is showing. Let me know in the comments what you think to that. Do you think that's a good idea or not? Let me know in the comments. Right, okay, so Atlantic hurricane activity next. This is all nice and straightforward, thankfully. So this is how the scores on the doors are currently looking for the 2020 Atlantic hurricane season. We have so far had 24 tropical depressions. We had 23 tropical storms, incredible number. 8 hurricanes and 2 major category 3 or above hurricanes. This has been a very, very big season for depressions and storms. This is the second biggest season on record, behind 2005 for depressions, for tropical depressions and for tropical storms. Where this season is lacking a little bit is with hurricanes. Well, that's quite a big number as well. 8 hurricanes is quite a lot, but also for major hurricanes, 2 in a very active season is quite a low number, actually. But of course, we've still got time to go with this hurricane season. We still have all of October left and even into November, so I would suspect there'll be at least a couple more majors before this season is done. We'll have to wait and see, but it is certainly a very big hurricane season that we have had. This has been updated by our good friend Schreien Bruin. So this is showing ACE, accumulated cyclone energy, for all hurricane seasons back to 1851. The classification is below normal, near normal, above average, or hyperactive. Let's scroll down through the years and through the decades, and we come down to 2020. So this up to the 26th of September, we see that the accumulated cyclone energy number for the 2020 hurricane season is at 101.08, 101.08 after 23 tropical storms, 8 hurricanes and 2 majors. That brings us out at a near normal ACE number for the 2020 hurricane season, which is quite strange. You would think that after having 23 tropical storms, we would either be above normal or hyperactive, but it's telling us that although we have had a lot of storms, many of these storms haven't been giving out all that much energy. They haven't been shifting all that much energy from the tropics to the poles, and so the overall ACE number is not all that far from average. However, I don't think it would take too many more storms or hurricanes to take us above normal. So if we get like another 1 or 2 hurricanes coming along, I think then this season will go above normal. But whether it ever quite manages to become hyperactive, that remains to be seen. Our last hyperactive season was in 2017. But yeah, very strange season this, to have so many tropical storms but a near normal accumulated cyclone energy. It is quite odd. Right, this is how Eurasian and Siberian snow cover is looking as of the 25th of September. This is from the National Ice and Snow Data Centre. So very little in the way of snow cover to be seen, actually. Of course, last week we confirmed that the Arctic melt season, which you see Arctic sea ice just here in this yellow area. So we confirmed that Arctic sea ice melt season reached its minimum. It was the second biggest melt season on record, and it's now started moving upwards. So the refreeze has commenced. We won't need to discuss that again. But in terms of Eurasian snow cover, actually lacking quite a lot with snow cover at the moment. Got a few little white patches here in the extreme eastern part of Siberia, but otherwise not much to be seen. For the first time this season, I'm going to run you through all years back to 1998 to compare. So this is how things look on the... So this is like the 25th of September 2020. Keep that in your mind, how that looks. Let's have a look at last year then. So this 25th of September 2019. Obviously, we have a lot more in the way of snow cover across Siberia, although there's not a great deal of it, but obviously there is more snow this time last year compared to right now. That is 2018, so yes, we are behind 2018 for snow cover as well. That's 2017, we are behind 2017 for this date as well. That's 2016, we are behind 2016 for snow cover also. That's 2015, obviously, yes, we are behind 2015 for snow cover also. That's 2014, we are well behind 2014 for snow cover at this point in September, and we're well behind 2013 as well, quite obviously, well behind 2013 too. That's 2012, so we're probably a little bit behind 2012, but not a great deal, there's not all that much difference between now and 2012, but probably a little bit behind 2012. That's 2011, we're behind 2011 as well, not greatly, but we are behind it. That's 2010, obviously we're behind 2010 as well, so we're doing very, very poorly for snow cover at the moment. That's 2009, what do you think about 2009? We're behind 2009, yes, but not greatly. So 2012, 2009, probably the 2 years that we're closest to. We're behind 2008, we're behind 2007, again, probably not greatly, but we are behind 2007. That's 2006, that's 2006, so again, behind 2006, but not greatly, not a great deal. 2005, we're a little bit behind 2005 as well, sorry about that. That's 2004, which we're behind 2004 also. That's 2003, what do you think about that? Yes, I think we're behind 2003 as well. It's been a very, very poor start to the Eurasian snow cover season, I have to say. That's 2002, well behind that. That's 2001, which we're behind as well. That's 2000, what do you think about 2000? Yes, we're definitely behind 2000 and 1999 and also 1998. We are behind both of those years. So there is no year back to 1998 that has less snow cover than we've got right now, actually, across Russia and Siberia, which may be a little bit alarming to some of you, but do bear in mind that, it's October that's the main year. It's how quickly the main month is, how quickly that snow line advances across Russia and Siberia in October that is key and is critical. So it may seem a little bit of a worry there, but I won't worry too much about that. But yeah, it is notable that there is no other year that has as little snow cover as we've got right now across Russia and Siberia. So it's a very, very slow start to this Eurasian snow cover season. I think the closest years are probably 2006, 2009, and maybe 2012. But even those years, we're a little bit behind them. Right, I'm going to pause the video there, and then we're going to look at ocean data. We've talked for half now. It's going to be quite a long one this week. It's going to be quite a long video because I've got all of the ocean data to go through next, and we will also be going through the archives and having a look at sea surface temperature all the way back to 1985 for the Atlantic, and I'm going to see you with that in around 2 seconds time. So more to come for this fourth winter 2021 update part 1. You're going to get yourself a cup of tea and some nibbles, and we'll see you back very, very soon. See you soon. Okay, we're back, and we're ready to resume the fourth winter 2021 update part 1. If you've enjoyed this video, please give us a like. Let us know in the comments what you think, and make sure you subscribe to GavsWeatherVids YouTube channel to be able to see more winter updates. We're going to be releasing the GavsWeatherVids Winter 2021 forecast on the 2nd of December. Right, so we're going to have to crack on very quickly now. So let's move on then. So we're going to look at sea surface temperature anomaly data for the rest of this update. So we've got our 4 areas of interest. We've got the ENSO region just here, the Equatorial Pacific Ocean. We've got the Northern Pacific over here. We've got the Indian Ocean over there, and then we've got the North Atlantic just here. That is how the sea surface temperature anomalies were looking when we did last week's 3rd winter update. Let's have a look at the very latest. This is the very latest. So yes, let's deal with the ENSO region first of all. We've got this massive blue here, cold and average sea surface temperature is stretching out along the equatorial Pacific Ocean. So yes, that's a signal of La Nina. That is La Nina through the equatorial Pacific Ocean. It's going to be a La Nina winter. Winter 2021 will be a La Nina winter. Let's see how things looked last week in that ENSO region compared to this week. There's been a little bit of cooling, I think, actually, particularly through this central part of the equatorial Pacific Ocean. I think the central part of the equatorial Pacific Ocean has cooled a little bit. Over on the eastern side, it just remains very much as it was. And out in the western part of the equatorial Pacific Ocean, again, perhaps cooled a little bit. But I think the main cooling over the past week, from last week to this week, has taken place in this central part of the equatorial Pacific Ocean. Again, what do we think about that? What's actually happened? What do we think about that? Yes, I think there has been a cooling through that central part of the equatorial Pacific Ocean. Over in the Indian Ocean, again, the Indian Ocean is just here. That's how things looked last week. This is how things look this week. Very little change. So we've got warm and average sea surface temperature is here in the eastern part of the Indian Ocean, cooler just here. That is a negative IOD, a negative Indian Ocean dipole that continues to develop. In the northern Pacific Ocean, again, that's how things look in the northern and in the northeastern Pacific Ocean last week. This is the latest. We're possibly seeing a little bit of a cool down, actually. I think things have cooled down slightly in that northeastern part of the Pacific Ocean. It's still significantly above average, but I think from last week to this week, there has been a little bit of a cool down. Then with this La Nina, we're thinking that these colder than average sea surface temperature anomalies are eventually going to get pushed out into the wider Pacific Ocean. So we are expecting, we're waiting for the northern Pacific to begin to cool down. That might have started. Let's have a look at the North Atlantic again, last week to this week. So that's last week, that's this week. Very little change in the North Atlantic. It remains pretty warm up here. It remains cooler through here, and it remains quite warm down in the tropical part of the Atlantic Ocean. So this is a change. This is from TroubleTidbits.com. This is showing the change in the oceans over the past week. 7-day SST anomaly change. And you can see that, yes, we have seen a cool down in this northeastern part of the Pacific Ocean. It's not cold on average yet, not by any means, but certainly the temperature anomaly has cooled quite substantially from last week to this week up in that northeastern part of the Pacific Ocean. We'll wait and see whether that continues. Also, we've seen sea surface temperature anomalies cooling here off the east coast of America. Again, not particularly well apparent on the chart from NOAA yet, but the anomalies are cooling down off the east coast. That's an interesting area to go cold. If that starts going cold around there, down that eastern coast of America, that starts getting very interesting. Then if it begins to go cold down the eastern seaboard. But yeah, on both sides of the states, it looks like the sea surface temperature anomalies are cooling a little bit. We have seen a further reduction in the sea surface temperature anomaly in the central part of the equatorial Pacific Ocean. This again from Tropical Tidbits confirming that the sea surface temperature anomaly is now down to around 1 degree below average, or very close to 1 degree below average, telling us that the La Nina is continuing to strengthen. That's where it was back in July. That's where it is now in terms of that temperature anomaly. So La Nina is continuing to strengthen. This is from the CFS V2. Let's pull this out. So CFS V2 now is going for a strong La Nina event. It's increasing the strength of this La Nina. The black dash line here, we've got temperature anomalies on the side, but dates and month periods on the bottom. So the black dash line now, which if you're on solid mean, going quite close to 2 degrees below average. That is a strong La Nina, and if it did come off, that would be our strongest La Nina probably since around 2000, sort of late 1990s, early 2000s. I would have thought it'd be a very long time since we have a La Nina that strong. So the CFS is continuing to increase the strength of this La Nina. A couple of months ago, it's only going for a weak event, then it moved to a moderate event, and now it is borderline strong. With this La Nina. SOI, which is the Southern Oscillation Index, I should say, is continuing to go positive. So this is from Queensland Government. So measuring air pressures between Tahiti and Darwin. And this column just here is the SOI number for each individual day. You see how most days that SOI number is positive on most days, telling us that the atmospheric setup is reflecting a La Nina. When the SOI is positive, the atmospheric setup in the Southern Ocean will be reflective of La Nina. When the SOI is negative, atmospheric setup will be reflective of El Nino. The red line, which is the 30-day ensemble mean, is continuing to lift up, as is the 90-day SOI average. So red line is the 30-day SY average, I should say. The orange-yellow line is the 90-day SY average. They're both lifting upwards, telling us that that this La Nina is continuing to strengthen and continuing to develop. So is the CFS right with this forecast for a strong La Nina to be in place by the end of the year? It will be interesting to see. Right, I'm just going to have another little pause of the video, and then when we come back, we're going to go through 35 years worth of sea surface temperature anomalies to try and pick out the closest matches in terms of the Atlantic sea surface temperature anomaly to this year. More in around 2 seconds time. See you in a mo. Okay, we're back and we're ready to resume the 4th Winter 2020-21 update part 1 for the final time, and we're going to go through 35 years worth of sea surface temperature anomaly data to try and pick out the closest match to this year in terms of Atlantic sea surface temperature anomalies. If you enjoyed this 4th update part 1, then please give us a like on the video. Let us know in the comments what you think. Make sure you subscribe to the GavsWeatherVids YouTube channel. It'd be absolutely great if you can do that. Right, so this, of of course, is how sea surface temperatures are looking as of the 25th of September. I want you to ignore the Pacific for this. So completely ignore the Pacific and the Indian Ocean. I want just to focus on the Atlantic Ocean. The reason being, mainly, is that the situation in the Pacific is very unusual, with like this proper landing and signal, but also a very warm northern Pacific Ocean. So very unusual what's happening in the Pacific at the moment. So ignore that. There won't be many years that match the current situation for the Pacific. Focus on the Atlantic. So that is how the Atlantic sea surface temperature anomalies are looking right now, from the tropics down here up to Greenland and the northern latitudes up there. That's how it currently looks as of the 25th of September 2020. And now we're going to scoot through all of the years. So that's 2019. So I think quite a close match actually to 2019, but not perfect for 2019. That's 2018. No comparison this year to 2018, really, so we can exclude that one as a match. That's 2017. Now, I think 2017 is a slightly better one. I think that is a slightly better year in terms of what the Atlantic is doing. Let me know in the comments which years you think are the closest match to this year in terms of the Atlantic. Again, ignoring the Pacific, we're focusing on the Atlantic. I think 2017 is one of the better matches. That's 2016. Again, I'm not keen on 2016 at all. That's 2015. No comparison. Look at that. The year of the cold blob. You remember that, I'm sure. The cold blob. No comparison this year to 2015. Right, let's carry on. 2014. Again, not keen on that one. 2013. No, I'm not really keen on 2013 either. That's 2012. I think, again, 2012 could be a slightly better match. 2017 and 2012, to me, are like two of the better matches here with this. But again, please let me know in the comments which year you think are the closest matches. 2011, not keen on that one. 2010, not really keen on 2010, but tropics isn't too bad, but to south of Greenland, much warmer in 2010. That's 2009, again, not keen on 2009. That's 2008. So that's a better one, I think, as well, 2008. 2007, no, not particularly keen on that one. 25th of September 2006. What do you think about that one? So that's perhaps a slightly better one as well. That's 2005. So again, what do you think about that? I'm not overly keen on 2005. That's 2000 and so we missed out 2004. Sorry about that. That's 2003. Again, not overly keen on 2003. 2002. Again, not particularly keen on that one. 2001. Again, not really overly keen on 2001. That's 2000, and I'm not keen on that one either. Right, much cooler in the tropical Atlantic in 2000, you'll notice. Right, let's carry on. This is 1999. Notice how the Pacific, again, I try not to focus on the Pacific. Look how cold the Pacific is back in 1999. That's cold PDO years, but we're focusing on the Atlantic. Again, not keen on 1999. Much cooler in the Atlantic in 99 compared to this year. That's 1998. Again, not particularly keen on 1998 either. That is 1997, not keen on that one. That's 1996, again, not particularly keen on that one. 1995, very different from now to 25th September 1995. That's 1994. We're moving back now towards the cold AMO era. So you notice the Atlantic is starting to become much colder in these years. That's 1992. Look how much colder the Atlantic is on the 25th September 1992 compared to right now. This is way back in the last proper cold Atlantic multi-decadal oscillation era. So none of these years are going to match, really, but I'll show you them anyway. This is 1990. Again, not really much of a comparison at all to this year in 1990. That's 1989. Look how much colder the Atlantic is in 1989, back in that cold AMO era. That's 1998. That's 1987. Again, there's no comparison to any of these years to right now. That's 1986. Much colder. This is the last year, 1985. And again, there is no comparison at all to this year. That's the kind of thing we've probably got coming, actually, in the next few years when we're going to go into the cold AMO proper. We're going to go into cold AMO proper in the 2020s, I think. So we will see the Atlantic getting increasingly cold as we move through the 2020s. But what years did you think were the closest matches? For me, it was 2019 was quite close. 2017 I thought was quite good. 2012 and possibly 2008, maybe 2006. Please let me know in the comments what you think. Lastly, if you have enjoyed this fourth winter 2020 update part 1, please can you give us a like on the video. Make sure you subscribe to the channel. Don't forget to tell your friends about GavsWeatherVids and our winter updates. And we've got a lot more to come over the next few weeks and months. Right, so that's it. 43 minutes. I wanted to keep these winter updates under 40 minutes, but we had so much to show you with this one. I hope you have enjoyed that look through the archives all the way back to 1985. This is content that you will see nowhere else on the internet. Certainly, you know, you're not going to see this in many places. Let's put it that way. So this is very unique content, and I hope you enjoyed that look at sea surface temperatures all the way back to 1985. If you did, then please give us a like on the video. So that wraps it up for the fourth winter 2020 update part 1. But we're going to be back actually tomorrow with part 2, and that is going to start looking at September data and the winter's winter analogs. So that's going to be a very interesting watch, and that will be coming up for you tomorrow at 6 p.m. The fourth winter 2020 update part 2. So I shall see you for that one from 6 p.m. And of course, we're going to see you at 6 p.m. tonight for our live stream. So no doubt we'll be discussing this winter update in the live stream, as well as looking at some long-range data for winter 2020-21 as well. So that's going to be coming up from 6 p.m. This evening. So I shall see you there for the fourth winter 2020-21 update part 1. That's all for now, and thanks for watching.